Geometry students. Today we're going to be looking at what happens when two chords intersect a circle. They're going to form these smaller segments by the vertex here. I'm going to label this right here a V for vertex. Now there are 4 segments in the circle, and I'm going to label this one A, point A, and this one O. And the reason I chose A and O will become apparent later. The next 2 I'm going to label I and E. Okay, so the segments that I'm going to use are AO and IE. Okay, so if I look at this, I'm not going to derive this formula right now. You're just going to have to remember it. But one thing that you should do is to say that there are 2 segments. One of them I'm going to highlight AO, and the other one I'm going to highlight IE. Now I'm going to use this pink one here. This segment right here from A to V could be labeled VA, segment VA, and the distance would be VA. If I multiply that by the other pink segment, VO, that would equal the product of the segments along the blue, which would be IV or VI, and VE. And so this is what we call the circle product. It's the formula we're going to use to solve all these problems. Vavo vive. Now in Portuguese that means grandma lives. So you can remember that if you're Portuguese. But anyway, Vavo vive might be rememberable in other ways. Maybe you could come up with the better one. I just came up with this one today just to make it easy to remember. Anyway, I'm always going to write this down to get started to set up these problems. Let's look at these first 2 problems here. Example 1. Now, when I'm given a circle, I have to recognize how to label these, and the V is always the intersection. That stands for vertex. The other 2 segments are going to be labeled AO and IE. Now I can set up my formula. Vavo equals vive. And then I just have to plug stuff in and I could solve for X, a missing segment in this circle. So VA, finding that, let's just go ahead and highlight this again. VA is this one here, that's 4, times VO, which is 6. That equals VI, which is 8, times VE, which is X. And we just solved that. 6 times 4 is 24. 8 times X is 8X. Divide by 8. We get 3 equals X. And so in this case right here, we have X equals 3 as our answer, and that is the length of VE. In the next example, we have to do the same process. We're going to label it, and then we're going to set up our equation and solve it. So go ahead and do that. Notice it doesn't matter which way you label it as long as AO is one of the segments and IE is the other one. Plug stuff in and solve. We have to be careful here because X times 3X is just 3X times another X. That gives us 3X squared because there's 2 factors of X. 6 times 8 is 48. Continue to solve. Divide by 3 first before we square root, order of operations. We get x equals 4 for our answer. And that looks pretty reasonable. That means that this segment right here, AV, I'll write down here AV equals 4, and VO equals 3 times 4, which is 12. So possibly I might want to find the two segments in the circle. The next situation is when two secants intersect outside a circle. So in this case, these have to intersect out here at an exterior point. That is where our vertex is. It's the intersection of the two lines. So same labeling. And now we're going to label one of the segments AO and the other segment IE. Just like before, we have segments, we have secants AO and IE intersect at point Now the secants continue on, but these are the segments we want to worry about. And the same formula holds. So we have Vavo Vive again. Well, it's a different case, but it's the same formula. That's our circle product. So what we're going to be using for these problems as well, but just the labeling is different. So in this first one, I'm going to label the vertex V. The first one is going to be AO. Doesn't matter what order we put that in to label this line AO. And then IE. And this line is IE. Now I can write my circle product and plug stuff in. So I have VA. So VA is all the way from A to V. And in my diagram, it's showing that that's 9 units all the way from A to V. So that's 9. VO, in my diagram, that's showing as X. VI is showing as 12. And VE is showing as 4. And that's basically the setup. Go ahead and solve. I just reduced the fraction. An improper fraction's fine, but you could put a decimal here. It'd be like, what, 5.3 repeating? For D, we're going to set this up again the same way. So remember, you have to start off with your letters. And we're talking about the secants AO and IE. That's really important that those are the segments we label. Now just plug stuff in. Now VO is a little different. That's from V to O, and we don't know how long that is, but we can break it up into 5 plus X, or X plus 5 for this segment. So it's X plus 5 from here, and I'm just going to draw that in so I remember that I'm just doing VO. Same on the other side, VI is 4, and VE is 4 plus 6 to get the outside. This is 4 times 10, so that is 40 on the right-hand side. Distribute the 5 on the left-hand side. I have 5x equals 25, well, plus 25. Continue to solve. We get x equals 3, and that's this segment here. So AO equals 3 if we want to answer it that way. And that's setting up these two particular equations. The third situation we're going to look at is when a secant and a tangent intersect outside a circle. So here, this must be the tangent. That's a point of tangency. And this one is a secant that passes through the circle, intersecting the circle in 2 points. So we're going to label this exactly as before. This is the vertex, and this is A. Notice that we don't have a point O because it only intersects the circle in one place. If we did put an O in there, it would be like over here, but that's our point of tangency. Maybe O is like over there. Doesn't matter where O is because we're only going to use A since it only intersects the circle in one place. On the other side, we have our I and our E. Now, when we do our circle product, we can write VA times, now we don't have O's over there and we're not going to include it. We're just going to do VA again. So interesting, VA times VA equals VI times VE. And that's Vava vive, which in Portuguese means go lives. Doesn't quite work. But anyway, you might be able to remember this formula, Vava vive. And example 3, we have a point of tangency here. We can tell that's a point of tangency because we see the whole line going past that point and only intersecting in one point. In F, we know it's a point of tangency because a radius and this segment make a right angle. So if the segment terminates at the circle, we're going to have some information that says that that's a tangent. But in these cases, both those are tangents. So we can use our formula. Now it's just a matter of plugging stuff in and solving. Oh yeah, and labeling, that's really the most important thing. The vertex is always where the two lines intersect. If it intersects in one point, we're going to start there with the A, and then we have our I and E for the other 2 points. So in this case, Va is X, and that's just X, and again X, and V is 8 plus 4 is 12, and VE is 4. So that's it. X times X is X squared. 12 times 4 is 48. So we take the square root of both sides, and we have X is approximately equal to 6.93 to 3 significant digits. We could also put this in simplest radical form if you remember how to do that. The square root of 48 can be broken down into the perfect square 16 times 3, and those can be done separately. Square root of 16 is 4, and the square root of 3 does not simplify. So x equals 4 root 3 is another way to express this answer. So for F, it's the same kind of thing. We have to label this. This is our vertex. This is the point of tangency A. This is I and E. And now we can plug stuff in and solve. One thing to remember here is when I'm calculating the distance VE, I have to know that this distance right here is going to be X plus 3X to E. And X plus 3X is going to be 4X because there's 1X plus 3X, and that's 4X. So that one's 4X. Go ahead and plug in everything and solve now. So after taking the square root, we get X equals 5. The next example involves these two problems. This one, H, is pretty advanced, so you can hang on to your hats for that one, but this first one's pretty straightforward. I want you to go ahead and do G from scratch. So go ahead and solve it now.